Okay, so on notes 8.4, we're going to be looking at rational, cubic, and cube root functions. So you should have your notes, and then you should have out your yellow sheet also. Okay, so on this first one, f of x equals 1 over x. That is a fraction. That is a rational function. So this is your rational parent function. We looked at this type of graph several units ago. Remember, it's like two separate parts. You have a vertical and horizontal asymptote, and we're going to talk about that in a few minutes. Okay, so the values that I want you to use for this is a -2. So when we plug in a -2 for x, we get 1 over -2, which would be -1/2. If we plug in a -1 for x, we're looking at that original function, 1 over -1 would equal -1. And then I want you to use, don't use 0, okay, because if you look at it, 1 over 0, that's going to make it undefined. You can't divide by 0. So I want you to use a -1/2. If you were to plug that in, you would have to keep, change, flip, and that would end up giving you -2. Because you would have to flip that -1/2 to a -2. Okay, and then I want you to use a +1/2. When you plug that in, you would have to keep, change, flip, so flip that 1/2. That would make it +2. And then we'll use 1, plugging it in, 1 over 1 is 1, and then plugging in a 2, you get +1/2. So those are the values that we're going to use on our rational parent function. Let's review real quick a vertical and horizontal asymptote. Okay, so vertical asymptotes, remember, is what causes your denominator to be 0. So we already talked about that. That would be 0, because if we plug a 0 in for x, we have 1 over 0. Okay, so the vertical asymptote would be x equals 0. The horizontal asymptote, remember when we talked about that, you're looking at the degree, which is your highest exponent. Notice on the top that there's no variable, so that would be a 0 on top for your degree. And then the bottom, we just have an x, so that exponent is 1. We compare those two. When 0 is less than 1, so when it's smaller on top, your horizontal asymptote was y equals 0. Okay, so let's start graphing, and then we'll look at domain and range. Okay, so I'm going to go ahead and draw my two asymptotes. My vertical asymptote, which means where it crosses the x at, it crosses it at 0. So I'll use blue. Crosses the x at 0, there's your vertical. Your horizontal is y equals 0, so it crosses the y at 0. So those are your two horizontal and vertical asymptotes. Okay, so now we're going to plot the points. So we have a -2, -1/2, -1, -1, -1/2, -2. And then notice we get to the positive values. So that side, I'm going to wait to graph. I'm going to go ahead and connect those. Because remember, an asymptote is where the line is approaching but never reaching. So that's only one side of it. Now I need to graph the positive one. So a +1/2 and a +2. So that would be there. 1, 1, and then 2/2. So there's the other side. Make sure that your lines are approaching the asymptotes but not reaching them. Okay, so this is a rational function graph. That's what it should look like. So anytime you see two separate parts, you know that it's rational. Domain for this, if you look at the x-axis, it's all real numbers except where your vertical asymptote is at, which is x equals 0. So your domain is all real except that vertical asymptote. So that would be x cannot equal 0, because we can't list everything out except 0. So you're just going to put x cannot equal 0. Your range, if you look at your y-axis, is all real numbers except your horizontal asymptote. So y cannot equal 0.
Hi.
Okay, so now we're looking at number 2. So on number 2, we have f of x equals x cubed. So that is the cubic parent function. Okay, so we're going to plug in, let's plug in a negative 2. So negative 2 cubed would give you a negative 8. A negative 1 cubed, negative 1 times a negative 1 times a negative 1 is a negative 1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. Okay, so we've seen a cubic graph before, but let's go ahead and plot those points. So negative 2, negative 8. Negative 1, negative 1. 0, 0. 1, 1. And 2, 8. Okay, so remember back when we were looking at cubic, it looks like a snake. So it curves. Your domain of a cubic graph is all real numbers because it's continuous both ways. If you look at the y, it's also all real numbers. So just like linear, cubic would be all real numbers for domain and range. Okay, so let's look at 3. Notice on this one we have f of x equals cube root of x. So this is the cube root parent function. Alright, so I'm going to start with, let's think about the smallest x value we could plug in and take the cube root. So the smallest would be negative 8. If we take the cube root of negative 8, we're going to get a negative 2. Because a negative 2 times a negative 2 times a negative 2. If we plug in, let's see, the next one would be negative 1. So if we take the cube root of negative 1, we're going to get negative 1, because a negative 1 times a negative 1 times a negative 1. Okay, so then 0, cube root of 0 is 0, and then 1, cube root of 1 is 1, and then we'll do the 8. Cube root of 8 is 2. So those are going to be your parent function values on a cube root graph. So let's graph these. We've actually not looked at a cube root graph before, so this should be something besides us looking at it whenever we were doing inverses. We've not actually said this is a cube root graph. So let's plot these points. Negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 8, 2. Okay, so it's like a sideways cubic graph. So domain, if you look, it's continuous both ways, so all real numbers. If you look at the y, it's also continuous, so all real numbers. So on linear, cubic, and cube root, your domain and range will be all real numbers no matter what your transformations are. Okay? Alright, so those are the 3 parent functions that we're looking at today. Okay, so the first one was rational, then we had cubic, and then we had cube root. Okay, so now let's look at some transformations. So let's look at number 4. Just like all the other functions that we've looked at so far, I want you to write down your transformations. And then once you have those written down, then you can shift your graph and look at your new graph. Okay, so 4. First, you have to determine what type of function you have. This is a rational because we have a fraction. Here's our parent function from the front. Remember, the values that we used were -2, -1/2, -1, -1. We didn't use 0 because 1 divided by 0 is undefined. So we used a -1/2 because whenever you flip that, because you're dividing by a fraction, that would give you a -2. Then we used a +1/2, which would give you +2. We used a +1 to give you a +1, and a +2 to give you a +1/2. So those are our parent function values. All right, so let's write our transformation down. So notice there's a negative in front. That is going to reflect over the x-axis. So it'll change your y values to the opposite sign. Then, notice we have a +3 after our parent function. That will be a vertical shift. So that will be up 3. Okay, so it's reflecting and it's shifting up 3. So notice on all of the other examples that we've gone over so far on the different functions, there was a 0, 0 point that we shifted. So if we look back at our parent function on the front, 0, 0, look at the graph, so right here, that 0, 0 is the intersection of your two asymptotes, your vertical and your horizontal. So that part is what you're shifting. So let's go back. All right, so we're going to go up 3. We don't have a horizontal shift, so we're just going up 3. 1, 2, 3. Now I want you to go ahead and draw your vertical line and your horizontal line passing through that point. So my vertical asymptote is not going to change because I didn't have a left and right shift. My horizontal asymptote will change. It went up 3. Okay, so you're shifting the origin still just like all the other functions we've looked at, but now our 0, 0 point was the intersection of those two asymptotes. Okay, all right, so from there, we're acting like that's the origin at this point right here. So that's our origin. We're plotting the same points from our parent function. But remember, we need to reflect. So whenever we reflect, we change the sign of each y value. So now that's a +1/2. That's a +1. +2. That will be -2. -1. And then a -1/2. So we're plotting those points from this point, or intersection point that we have on our graph. So I'm doing -2, +1/2, because I'm having to reflect. So go left 2, up 1/2. Then left 1, up 1. Left 1/2, up 2. And there's the left side of our graph. So go ahead and connect those. Make sure that you don't intersect those asymptotes there. All right, the other side, we have a +1/2 and then -2. +1, -1. +2, -1/2. So we're acting like that's the new origin. So connect your points, approach those asymptotes there. Okay, so we found the new asymptotes just by shifting our transformation. Okay, so you can either look at the back of the function to find your vertical and horizontal asymptotes, or look at your graph since you already have them on the graph. So your vertical is always x equals. So notice x equals crosses the x at 0. Okay, the reason it didn't change is that's what causes my denominator to be 0, which is 0. Your horizontal changed. It went up 3. Now it's at y equals 3. Okay, so my domain, remember, is going to be all real numbers except what causes your denominator to be 0, which is your vertical asymptote. So that would be x cannot equal 0. Because notice we're using all of these x values, but not 0 in the middle. The range is also all real numbers, but it's except that vertical or that horizontal asymptote. So y cannot equal 3. You can look at it here. You're not using that y value there, but all the other y values. Okay, so the rational is a little more confusing than the other types of functions that we've looked at. Okay, so let's try another rational function on number 5. So this is rational. The points on our parent function, 1 over x, remember is negative 2, negative a half, negative 1, negative 1. 0, remember we can't plug in, so we used a negative a half, which would give us a negative 2. And then we use positive 1/2, which would give us a positive 2. 1, 1, and 2, 1/2. Okay, so let's write our transformations down. Okay, looking at our function here, notice that we have x plus 2 in the denominator. If we look back up at 4, we did not have anything that we were adding to x in the denominator. So when it's with your x, just like when we had parentheses or square root, when it's with your x, it's a horizontal shift. So remember, if it's x plus 2, it's going to be going to the left that many units. So left 2. And then the minus 3 is after your fraction. So that's a vertical shift. So down 3. Okay, so remember on the rational, you're shifting the 0, 0, the origin, which is the intersection of your two asymptotes, the vertical and the horizontal. Okay, so I need to shift left 2 and down 3. So I'm going left 2, down 3. So plot that point. Once you've plotted that point, then you can draw your vertical and horizontal asymptotes. They need to cross through that point. So that's my new origin. We shifted it. Notice that we don't have a reflection, we don't have a stretch, we don't have a shrink. So once you have shifted that, now you're just plotting your points from your parent function. So looking at this table here. So from that point that we found that we shifted, you're going left 2 and then down 1/2. Left 1, down 1. Left 1/2, down 2. So there's our points. We can go ahead and graph that side of it. And then we're graphing the other side. So I'm going right 1/2, up 2. Right 1, up 1. Right 2, up 1/2. So there's my graph there. So again, on your vertical and horizontal asymptotes, you can just look at the graph and look at those asymptotes that you shifted, or you can look at your function, whichever way. If you're looking at the function, remember the vertical is what causes your denominator to be 0, which would be -2. If you look at the graph, notice the vertical line here crosses at -2 on the x. The horizontal asymptote, remember, is your degree, which is 0 on top, 1 on bottom. And actually you can't use that. So we're just looking at the graph. Okay, so when you look at the graph, it went down 3, so it should be y equals -3. The reason you can't use that degree is because you have that -3 after your fraction. Okay, so domain of your rational is all real numbers except the number on your vertical asymptote. So x cannot equal -2. Range, all real numbers except the y value of your horizontal asymptote. So y cannot equal -3. You can also just look at the graph and determine that. What x value is not being used, -2. What y value is not being used, -3. But all the other ones are being used. Okay, so that was the rational. So now let's look at 6. You need to determine what type of function it is. So this would be cubic because we have a cube there. Here's your cubic parent function. We talked about it on the front. Okay, so we plugged in a -2 and we got -2 cubed, -8. We plugged in a -1 and got -1. We plugged in 0 and got 0, 1, 1, and 2, 8. So those are our parent function values. Okay, so let's write our transformation down. The negative in front is going to reflect it, or change your y values to the opposite sign. After your parent function x cubed, we have a -5, which means vertical shift. So that would be going down 5. So let's refresh our memory and go back to the front and look what our parent function looks like on cubic. So it looks like a snake that increases from left to right there. Okay. Notice it does have a 0, 0 point. So that's what we will be shifting. Alright, so we're shifting our 0, 0 point. We need to go down 5. 1, 2, 3, 4, 5. So there's our new middle of our cubic graph. We also have to reflect. Remember, that means we're changing the y values to the opposite sign. So now that will be 8. That will be 1. The 0 doesn't change because we shifted that. That will become -1. And then -8. Alright, so let's plot those points. This is our new origin. We shifted it. We're doing left 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Left 1, up 1. Right 1, down 1. And right 2, down 8. Notice the down 8, we're not going to be able to do that. So these are the only points that we can plot here. So it should be a straight line, okay, with a little curve. So notice this time it's decreasing from left to right because of the negative in front. All right, your domain and range. Remember I said on linear, on cubic, on cube root, your domain range is going to be all real numbers because it's continuous both directions. Okay, so we are going to stop there for today because notes are really long. So we're going to stop with this, and you're going to go ahead and get your assignment. So go ahead and do the ones that you think you can do today. You need to work on it. Also, on your yellow sheet, I want you to go ahead and transfer on the front. I want you to transfer number 1, that's rational. Number 2, that's cubic, and then number 3, that's cube root. You're going to transfer those to your yellow sheet, okay? So you're going to transfer those, work on your assignment, and then tomorrow you're going to finish the notes. Okay, once you finish the notes, then you'll have some more time to work on 8-4 again. So make sure that you're doing what you're supposed to be doing and working on the yellow sheet and on 8-4.